Hi guys, I love and I miss y'all. I wish we were together. I just need you to understand that this is super awkward for me to record myself and to be teaching to a phone. Therefore, I know it is probably extra awkward for you to sit here and watch me. So my goal is to keep all of my lectures under 10 minutes. So I am going to move fast. But just remember that you can always rewatch it. You might even be able to, you can press pause and play. But what I would do if I were you is if you're on here, you've probably seen the guided note sheet that I put on Google Classroom. You will have one of those every week. You can either print it out or you can just grab a sheet of paper and kind of make an outline just like this and then write on there. Or what I would do is I would get a sheet of paper, kind of make an outline like this is, and then I would also pull up the 5 questions that are due this Friday or write them down. That way when you're watching this video, you can also be looking at the questions and answering them as you go. That's just me, but you do it however you want to. I apologize if I move fast. I just know that you want to do other things, so I'm not going to try to waste your time. Okay, we are going to start talking about probability. There are multiple different probabilities, or like ways to types. There's multiple different types of probabilities. The reason that we are going over this is going to give you a foundation for whenever you may take Miss French's statistic class, or you may take it in college, or you may not take it at all. Oh my god. But probability is still good to know because it's like fractions, the probability that we're gonna have a tornado, all that kind of stuff. So we're gonna talk about 2 different types of probability today. That's experimental and theoretical. We'll move on to different ones next week. I am not going to go through the definitions because they are on your note sheet and you can read them yourselves, but I am going to give you examples. So an example of an outcome is like rolling a die and getting a 1. You rolling that 1 from the dice is your outcome, okay? Or having a deck of cards and you pulling out the King of Hearts. The King of Hearts is your outcome. All right, the event is like you having that deck of cards and pulling something out. The event is you rolling the dice, okay? Whatever you're doing, whatever you're looking for, okay? The event is how many tornadoes have gone through in April, that kind of thing. Okay, this sample space is the set of all possible outcomes. So if you're holding a dice, the dice has 6 sides, so there are 6 possible outcomes, okay? If you're holding a deck of cards, there's only 4 suits, so if you were looking just at suits, you would have 4 possible outcomes. Stuff like that, okay? So probability, I am going to read this definition. The probability of an event is a measure of likelihood that an event will occur. It is numerical value from 0 to 1. That's why we talk about fractions, okay? It can be presented as a ratio, a decimal, or a percentage. So the first type that we're going to talk about is experimental. Experimental would be based on the actual result of an experiment. So say my experiment was I gave you a die. Actually, I gave you a die, and I said you need to roll it 20 times. And every time that so roll it 20 times, and I need you to write down each time that you roll a 6, okay? What is the probability that you're going to roll the 6? But you're doing the experiment, therefore that's what makes it an experimental probability. So that equation is going to be the probability of the event, so the probability of it happening is equal to the number of favorable outcomes observed over the total number of trials. So if we were talking about that die and I wanted you to roll the 6, the number of favorable outcomes would be how many times you rolled the 6 over the 20, because 20 is the number of trials. Cool? Cool. So, that sample problem. It says, a sales associate checks the t-shirts available in the storage. He found that 7 were white, 8 were blue, 11 were red, 5 were green, 9 were yellow, and 10 were a variety of other colors. What is the experimental probability for each outcome? What that means is, A, it says, what is the probability of picking up a white shirt? Well, there are 7 white shirts, so 7 is going to be your top number. Your bottom number is going to be all of the other t-shirts added up. So, if I were to give you this example, you would have 7 over 7 plus 8 plus 11 plus 5 plus 9 plus 10, which is 50. So the probability of getting a white shirt would be 7 over 50. Okay, easy peasy. If you get a fraction that you know you can reduce, you need to reduce it. So let's go to letter B. So what is the probability of getting a blue t-shirt? Well, there are 8 blue t-shirts. So 8's going to be your top number. Your bottom number is still going to be 50. But 8 over 50 can be reduced. Okay? 8 over 50 can be reduced to 4 over 25. So 4 over 25 is actually going to be my number, or my answer. Okay? So if you get a fraction and you need to reduce it, reduce it. I'm going to let y'all finish those examples. Oh, man. That was sad. All right, B, no, not B. Well, the next type, theoretical probability of an event measures the likelihood that the event occurs based on mathematical reasoning. So that's kind of like where the statistics comes in. So the probability of the event, here's your equation. The probability of an event is equal to the number of favorable outcomes over the number over the number of all the possible outcomes. So the number of favorable outcomes, so if I'm rolling that dice again, my favorable outcome is rolling a 6. The number of all possible outcomes is 6, because there's only 6 sides to a dice. So if I were to roll just 1 6, it would be 1 over 6. Okay, there's samples on the back. So we're going to use this wheel. The wheel has numbers 1 through 8 over it. And it says, use the wheel to find each theoretical probability. So A says, what is the probability of spinning that wheel and it landing on an even number? Well, this row of numbers over here just tells you the numbers that they're looking for. So the even number is 2, 4, 6, 8. Okay? So there's 4 of those numbers. So it wants to know what is the probability that we're going to land on either 2, 4, 6, or 8. So 4 is your favorable outcome because there's 4 even numbers. And then your bottom number is 8 because there's 8 possible outcomes. So 4 numbers that you want to get over 8 of the total that you want. And then of course there's, you have to reduce it, so it reduces to 1/2. Okay? I'm going to let you go through the rest of them because I know you can do it. To end this out, the complement of an event consists of all the possible outcomes in the sample space that are not part of the event. So like, if I wanted to roll a 6, but I always rolled a 3 or a 4, like those are my complement. So the probability of it not happening is equal to the number of unfavorable outcomes over the number of all possible outcomes. So if I'm rolling that die and I want to roll a 6, there's 5 other numbers that I could get, okay? But there's 6 possible outcomes. So there's going to be 5 unfavorable, 5 possible things that I don't want to happen over 6 possible outcomes, okay? So then it says the sum of the probability of an event and the probability of its complement is 1. So the probability of something happening plus the probability of it not happening will always equal 1. So another way you could look at it as a probability of something not happening is equal to 1 minus it happening. So if I wanted that fraction of 1 over 6 like I talked about earlier, and I wanted its complement, I could take 1 minus 1 over 6, and it is equal to 5 over 6. So that sample problem down at the bottom, find the theoretical probability of each outcome enrolling a standard number cube. So well, what is the probability of rolling a 4? This is just like my example of rolling a 6. Excuse me. The probability of rolling a 4, there's only one 4 on there, and there's 6 possible outcomes. So I'm going to have 1 over 6. 1 over 6. Because if I need to get a die. If I had a dice and I rolled it, I want to land on a 4, but there's 6 possible numbers that I could get. Okay? And then B says, what is the probability of not rolling a 4? Well, if I know what it is rolling a 4, all I have to do is subtract that from 1. So I'm going to take 1 minus the probability of not rolling a 4. So 1 minus 1 over 6, which is equal to 5 over 6. So 1 minus 1 over 6 is equal to 5 over 6. So let me recap. Today we learned about experimental and theoretical probability. Experimental has to do with you actually doing it, and remember that bottom number is the number of how many times you're going to do it, okay? So the total number, whereas theoretical probability is the total of possible outcomes, okay? So experimental probability, I have to roll the dice 20 times. Theoretical probability, there's only 6 sides, okay? Hopefully I will be able to get a whiteboard to put behind me sometime soon to make this a little bit easier. If you have any questions about the 5-question Friday, you're going to turn it in exactly like you did last time. Just let me know. Yeah, I wish we were together. This would make this a million times easier, but these are the cards that we'll dealt, and we'll get through it. I love y'all. Do not stress. Happy Monday.